While the world's naval focus has remained fixated on aircraft carriers, stealth destroyers, and hypersonic missiles, a quieter shift has been unfolding in China's shipyards. It's not about new metals or next-gen propulsion. It's about concrete. Yes, concrete ships. A concept dismissed by many as an outdated wartime experiment is now being revived by China with a level of precision and purpose that has taken military observers by surprise. What was once seen as a stopgap solution is now being reimagined as a strategic asset. New concrete vessel designs are stronger, longer lasting, and, in many cases, cheaper to maintain than their steel counterparts. They don't corrode in salt water like steel, and they require significantly less upkeep over time, something that could give China long-term advantages in cost and deployment durability. U.S. analysts are starting to sound the alarm. What initially seemed like a curiosity is now viewed as a calculated move, an unconventional but clever strategy that could have serious implications for maritime balance. These aren't ships meant to dominate headlines with sleek profiles or high speeds. They're meant to endure, to operate under the radar, to survive where steel might fail. And that endurance is quickly becoming a focal point in the evolving chessboard of Pacific power. Because while the West races to develop faster and more agile fleets, China may be investing in something far more quietly effective: ships that simply never die. The World Wars, when concrete ruled the seas. This isn't the first time concrete ships have taken to the seas with strategic value. Their origins stretch back over a century, when global conflict made steel a luxury few nations could afford. During both World War I and World War II, the United States, Britain, and Germany built fleets of reinforced concrete vessels to fill gaps left by steel shortages. These weren't just experimental prototypes, they were workhorses of war. The U.S. launched dozens of concrete tankers, cargo ships, and barges. Germany used them for troop transport and coastal defense. Britain relied on them for logistics, even anchoring some to serve as artificial harbors during the D-Day invasion. Their resilience in battle and resistance to corrosion proved they weren't just functional, they were durable. Some of these ships continued serving decades after the war ended, transformed into docks, storage units, and even civilian structures. The fact that many still exist today, structurally sound and often in use, is a testament to the material's surprising longevity. So when China looks to concrete in 2025, it isn't reaching into fiction, it's pulling from history. The lessons of wartime innovation are being modernized with today's technology, engineering, and geopolitical context. Concrete ships once helped win wars out of necessity. Now they may help shape the future by design. And as China revives this old tactic, the U.S. must reckon with an uncomfortable truth. What once seemed obsolete may now become a foundation of maritime strategy. Why concrete, the secret material weapon? On the surface, concrete may seem like a strange choice for shipbuilding, a material more associated with bridges and buildings than with wave-battered hulls. But when looked at through the lens of durability, stealth, and survivability, concrete offers a set of advantages that steel simply can't match. Unlike steel, concrete doesn't rust. It shrugs off saltwater corrosion and can remain structurally sound for over a century with minimal maintenance. It handles impact differently, absorbing shock rather than transferring it. Against collisions, ice, or explosions, that resilience could be the difference between a ship limping home and one sinking beneath the waves. Then there's stealth. Reinforced concrete is non-magnetic, making it inherently resistant to magnetic naval mines, an advantage that could prove critical in contested waters. Concrete also absorbs sonar differently, offering potential for passive stealth applications in submarine-heavy zones. For logistics, fuel storage, or mobile command centers, concrete is also highly stable. It holds temperature well, making it ideal for refrigerated or flammable cargo. And when reinforced correctly, it can handle massive structural loads, ideal for modular or expandable naval platforms. These traits aren't just theoretical, they're being put into practice right now in Chinese shipyards that are blending modern composite science with ancient material wisdom. The result isn't just a ship that floats. It's a vessel that endures, adapts, and quietly threatens to change naval architecture as we know it. As others chase speed, China is chasing permanence. And it's that slow, methodical approach that might prove to be its secret weapon, the surprising strength behind reinforced concrete. The true genius behind concrete ships lies in the reinforcement, steel rebars embedded within layers of meticulously cured cement. This combination creates a hybrid material that isn't just strong, it's versatile. Reinforced concrete can resist both compression and bending forces, making it ideal for the stresses of ocean travel and cargo loads. Modern techniques have further enhanced these properties. High-performance mixes now include additives that increase tensile strength, reduce permeability, and accelerate curing. This makes the material less prone to cracking, even under shifting ocean pressure or fluctuating temperatures. Heat, once a concern in marine engineering, becomes a hidden strength. Concrete's slow response to thermal changes makes it ideal for transporting heat-sensitive goods or housing sensitive electronics in mobile command roles. Unlike steel, which can rapidly expand and contract, concrete moves slowly, reducing mechanical stress over time. China's engineers are taking this even further. Advanced composites and fiber reinforcement are replacing some of the traditional rebar, reducing overall weight while boosting resilience. Combined with smarter hull designs and modern HIAD modeling, today's concrete ships look nothing like their lumbering World War II ancestors. They're sleeker, smarter, and more structurally optimized. As the material science evolves, so too does the potential application. What was once limited to stationary barges or slow-moving tankers can now be reimagined as mobile bases, modular supply platforms, and even semi-autonomous cargo haulers. This isn't about replacing steel everywhere. It's about choosing the right tool for the right mission. And reinforced concrete, once forgotten, is proving to be more capable than anyone expected. Why the US abandoned them, and why China didn't. In the aftermath of World War II, America's shipyards shifted away from concrete with almost surgical decisiveness. Steel had become cheap and abundant again, and with fuel efficiency taking center stage, the heavier, slower concrete vessels quickly fell out of favor. For a time, the decision made sense. Speed and agility won Cold War naval encounters, not raw resilience. But that same logic didn't hold everywhere. In China, where labor costs were lower, shipbuilding capacity was expanding, and strategic needs were shifting, concrete wasn't discarded. It was shelved, studied, and eventually refined. And as China's military began prioritizing long-term presence and durability over maneuverability in certain theaters, the material made a quiet comeback. Now, with improved materials, AI-driven design, and a rising focus on cost-effective, sustainable infrastructure, the drawbacks that once doomed concrete are being engineered away. Heavier ships? Not a problem when speed isn't the mission. Fuel efficiency? Offset by lower build and maintenance costs. Structural thickness? Compensated by smarter internal layouts in distributed systems. China's approach isn't about making concrete ships replace destroyers or carriers. It's about building durable, low-cost vessels that support the broader force. Floating warehouses, hardened fuel reserves, mobile command hubs. Vessels that don't need to outgun or outrun, they just need to outlast. And as China builds them in volume, the US must reckon with a hard truth. What it once dismissed as obsolete, China may turn into an asymmetric advantage. China's maritime masterstroke, strategic utility over speed. In a world obsessed with velocity, China is embracing a different doctrine, utility. Its investment in concrete ships isn't about building the fastest vessels. It's about creating the most useful ones. In contested zones like the South China Sea or potential flashpoints near Taiwan, what matters more than speed is presence, persistence, and survivability. Concrete ships, particularly those designed to act as mobile supply depots or floating fuel reserves, fit this strategy perfectly. Their inherent durability means they can operate closer to hostile waters without the constant need for port maintenance. Their low magnetic signature makes them less likely to trigger mines. And their bulk? That's not a flaw. It's armor. In wartime scenarios, these vessels could act as logistical lifelines, impossible to take out with a single strike, too low profile to prioritize, but absolutely essential to the machinery of war. China is also exploring their use as decoys, drawing fire from more valuable assets, or as hardened mobile bases capable of launching drones, storing munitions, or hosting communication arrays. The logic is simple. Why build 5 high-value ships when you can build 50 rugged ones that just won't go? Away? In the age of precision warfare, dispersion and survivability are critical. Concrete ships provide both, and at a fraction of the cost. And that's what has U.S. naval strategists worried. Because this isn't a flashy headline, it's a slow, creeping transformation of the seascape, one that could redefine maritime power not through dominance, but through unshakable presence. Concrete versus steel, the hidden trade-off. As the global naval landscape evolves, a quiet but significant materials debate is resurfacing. Concrete versus steel. It's not just a question of tradition, it's a question of trade-offs. Steel, long the standard in shipbuilding, is favored for its strength-to-weight ratio and ease of fabrication. But it also corrodes, requires constant maintenance, and becomes a liability in certain extreme environments. Concrete, on the other hand, is heavier and bulkier, but it endures. The difference comes down to priorities. Steel is better suited for speed, mobility, and high-performance applications. It's the go-to for warships that need to maneuver quickly or support sophisticated combat systems. But when it comes to long-haul cargo, stationary platforms, and missions where survivability outweighs speed, concrete quietly wins. It can absorb more impact. It doesn't rust. It lasts longer without constant upkeep. Yes, concrete hulls are thicker, often 10 times thicker than their steel equivalents. That increases displacement and lowers the cargo-to-weight ratio. But in roles where movement is minimal or unnecessary, such as floating fuel depots, resupply stations, or fixed sea platforms, that drawback becomes irrelevant. China understands these trade-offs well. Instead of trying to outdo U.S. steel warships, it's building an alternative model of power, one based on sheer staying power, not agility. In this way, concrete becomes more than just a material. It becomes a strategy. And it's one the United States can't afford to ignore. Because if China deploys enough of these ships in key locations, they could create a web of unsinkable infrastructure that supports naval operations without ever firing a shot. The legendary ships that refuse to die history has a way of leaving behind relics that speak louder with time. Among them are the nearly forgotten concrete ships built during the World Wars, vessels that were supposed to be temporary solutions, but became something far more enduring. These hulking giants, once dismissed as outdated, are now proving to be some of the most resilient structures ever placed in water. Take the SS San Pasquale, for example. Launched in 1920, this concrete ship has been repurposed countless times, from a fuel tanker to a floating prison, and now a hotel. Over a century later, it still floats in the Caribbean, a living monument to the longevity of concrete engineering. Then there's the SS Peralta, built in 1921 and still standing as a breakwater on the U.S. West Coast, quietly resisting the tide and weather that have broken steel ships in half. Across the Atlantic, remnants of Germany's 1940s concrete fleets have become tourist attractions, stubbornly intact despite decades of exposure to the elements. In every case, these vessels have resisted not just corrosion, but history itself. Their survival isn't an accident, it's evidence. This legacy is not lost on China. These ships are more than marine oddities. They're proof of concept. In a world where climate, conflict, and resource scarcity are reshaping strategic priorities, longevity has become a form of strength. China's engineers are learning from these century-old vessels, improving upon their weaknesses, and building the next generation to last even longer. In reviving concrete shipbuilding, China isn't just looking forward, it's reaching into the past, extracting what worked, and combining it with modern science to create something uniquely powerful and potentially unstoppable. China's modern reinvention: smarter, lighter, stronger concrete. Today is not the concrete of 1942. Through advances in material science, China has managed to take an old idea and evolve it into something surprisingly sophisticated. By using high-performance aggregates, fiber-reinforced polymers, and 3D printed components, Chinese engineers are drastically improving what concrete ships can be: lighter, stronger, and more adaptable than ever before. In particular, the integration of smart composites, materials that respond to stress, temperature, and vibration, allows for more intelligent monitoring of a vessel's health in real time. Where once concrete was seen as heavy and inflexible, new formulations are now rivaling steel in strength while reducing overall weight. Innovations in curing methods also enable watertight, pressure-resistant structures that can last decades without significant maintenance. But what truly sets China's new concrete ships apart is design optimization. Using AI-assisted modeling, naval architects are creating sleek, hydrodynamic hulls that minimize drag and improve stability, making these ships more efficient than their forebears ever were. Additive manufacturing, especially large-scale 3D printing, allows for customized modular parts that can be rapidly produced and assembled without traditional dry docks. This transformation isn't about nostalgia, it's about function. The new generation of concrete vessels aren't trying to compete with steel warships. They're carving out a new category. Think mobile refueling stations, drone launching barges, or disaster response platforms that double as command centers. These aren't ships built to race. They're built to endure, adapt, and deliver. China's reinvention of the concrete ship is a masterclass in rethinking legacy technologies. And with each iteration, they move closer to building a fleet not defined by appearance, but by quiet, unshakable capability. Tactical and economic advantages. In modern warfare and logistics, cost is just as critical as capability. China's concrete ship strategy doesn't merely rest on durability, it thrives on efficiency. Compared to traditional naval vessels, concrete ships require less refined steel, fewer specialized welders, and can be built using local materials in remote shipyards. That makes them not only cheaper, but also faster to produce. At scale, these advantages become strategic multipliers. In a hypothetical conflict or global embargo, China could continue building or deploying concrete vessels without depending on international steel markets or complex industrial parts. This supply chain resilience gives China a serious edge in long-duration operations, especially in resource-constrained environments like the South China Sea or contested Pacific Islands. Moreover, maintenance costs are dramatically lower. Steel ships require constant anti-corrosion measures, repainting, and inspections. Concrete, by contrast, weathers the ocean more gracefully. Its resistance to salt, heat, and impact means fewer dry dock visits and more time at sea. Over decades, that translates into major operational savings, especially for non-combat roles like supply, fuel, and logistics. From a tactical standpoint, these ships provide vital infrastructure: floating fuel depots, emergency ports, even mobile repair stations. Their simple, rugged design allows them to operate in places where traditional naval assets might be too vulnerable or too expensive to risk. What's clear is that China isn't just reinventing the ship, it's reinventing how you use ships. And in a future where fast, cheap, and durable wins the war, concrete vessels could become the new maritime currency of power projection. US panic: what if China builds a fleet of unsinkables? It's not speed or firepower that has American naval planners most concerned, it's survivability. As whispers grow louder about China's concrete fleet expansion, a haunting scenario takes shape. A network of unsinkable, low-signature vessels scattered across strategic choke points. Ships that don't need to outrun missiles because they're too durable to destroy in one strike. Platforms that can resupply fleets, store weapons, and even launch drones, all while shrugging off the corrosive wear of ocean deployment. This is what keeps Pentagon wargamers awake at night. If China builds these vessels in volume, traditional naval blockades could become nearly useless. Attacking them would require more munitions than most conflict scenarios budget for. Tracking them could prove difficult due to low magnetic and sonar signatures. And even if one were damaged, its rugged construction means it might still remain operational. Crippled but functional, a floating problem that won't go away. These ships could also serve as dispersible infrastructure, spread across international waters, reinforcing China's presence and influence without the provocation of deploying full warships. In a conflict scenario, they become logistical cockroaches, hard to kill, everywhere at once, and strategically disruptive. What's more concerning is how quickly they can be built. With modular construction, local materials, and a focus on function over form, China could quietly scale up this fleet without the West even noticing, until it's too late. In the game of modern naval warfare, dominance doesn't always come from destroyers and carriers. Sometimes it comes from what refuses to be destroyed. The future of maritime warfare may be. Concrete steel may still define the sleek silhouette of modern navies, but beneath the surface, a new contender is rising. Quiet, unshakable, and slowly. Changing the face of maritime strategy. Concrete, long dismissed as a relic, is now being reborn as a backbone of China's future naval doctrine. What makes this shift so profound isn't the material itself, it's how it's being used. China's defense planners are exploring applications far beyond simple supply ships. Modular floating bases, drone launch pads, missile-ready barges, and mobile refueling hubs are all part of the playbook. These are not ships for combat, they are the support skeleton of a new kind of sea power. In remote theaters like the Arctic or the South Pacific, where infrastructure is scarce and weather conditions extreme, concrete ships can serve as semi-permanent installations. Immune to salt and corrosion, resistant to missile damage, and easily anchored where needed, they offer a flexible solution for power projection and rapid response. They're not glamorous. They don't boast cutting-edge stealth or sleek radar profiles, but they work. And in war, that's often what matters most. China is betting that the next generation of maritime superiority will come not just from how fast or how far a ship can go, but how long it can stay, how much it can carry, and how well it can endure. That bet might be right. And if it is, concrete could become the unexpected cornerstone of 21st century naval warfare. History repeats with a technological twist. It's often said that history doesn't repeat, but it does rhyme. The story of concrete ships is one of wartime necessity, post-war dismissal, and now high-tech resurrection. A concept once born from scarcity has returned, not out of desperation, but through deliberate, strategic reinvention. China isn't just reviving the past, it's re-engineering it with tomorrow in mind. What was once considered obsolete, it is being turned into a potential game changer. With AI-optimized designs, advanced materials, and 3D printed reinforcements, today's concrete vessels bear little resemblance to their lumbering predecessors. They're not replacements for warships. They're reinforcements for strategy. Silent, durable, and far harder to eliminate than any traditional naval asset. The U.S. now faces a critical choice. Dismiss this as a novelty again, or act. Because if ignored, this quiet revolution could blossom into a full-scale fleet that reshapes the oceans, not through force, but through permanence. And as China continues laying the groundwork, one thing becomes clear. The next war at sea may not be fought by what sails the fastest, but by what simply refuses to sink.